Then let me start. Thank you for joining today. My name is Takashi. Yeah, you can see the slide. The topic I would like to show today is about kernel firmware, but not about the kernel itself, but rather packaging. So it's not too much technical, but yeah, well, I hope you can enjoy. So this is outline. It means just we follow the history of the kernel firmware packaging. Yeah, we go together for the long journey. The kernel firmware is basically the definition, the low-level binary blob that is loaded to the device or CPUs by the kernel. Due to its nature of the kernel firmware, it has been always present with the kernel development. And in the early days of the kernel, there was no standard at all. So every driver was responsible to load the kernel and manage the kernel firmware. And so because of that, the kernel source had many static embedded hex code, so the binary blob in the kernel source itself, or the firmware files were placed on the different places, like under etc or whatever else, or the firmware files itself was distributed from different projects on the internet. So we had to gather from different projects and combine so many things. The situation changed slightly better in the early 2000s. So the kernel introduced request firmware API. A few years later, Linux firmware Git tree was created. And at the same time, we also created the kernel firmware package for the OpenSUSE and SUSE. So this is a starting point of our journey. Let's start the adventure. The Linux firmware Git tree is is a central place for the kernel firmware package. So it was started from putting the static binary hex code from the kernel source tree. And that was one of the, I guess, the motivation of the Linux firmware Git tree, because the kind of binaries are always gray zone from the license point of view. So that it was cleaning up the kernel source code. And later on, the Linux firmware Git tree gathered many firmware files from other projects, like other firmware or video for Linux or whatever else. And since then, many vendors participated. For example, Intel Wi-Fi and AMD CPU microcode and so on. But there are still a few firmware files that are not put on the Linux firmware Git tree, where it's okay, but there are some such things too. The structure of the Linux Git tree is very, very simple. It's first of all, it has a single large text file called whence, and it lists up all firmware files and license information, symbolic links, whatever else. It looks like that. So it consists of sections of each driver. And each section contains a driver, describes a driver, and it shows which files belong to that, also which license or whatever meta information. And the rest of the Linux firmware Git tree, almost all the rest, are firmware files and license was other text information. So really, it's pretty simple structure. And our packaging initially was also very, very simplistic. Just copy the old data into the under the lib firmware. And later on, there was some more cleanups to not to include the unnecessary files and so on. But basically, it remained the same for a long time. So this is a steady phase. That request firmware API didn't change so much itself, and so remains stable, although the kernel had a different, underlying changes. For example, the direct firmware loading support that was done by Linus himself, or then changing, what was this? Yeah, caching support and so on. But it was easy. However, adventures has always trouble, as you know. And then later on, so that was year 2019. Yes, the Linux firmware 3 grows over 500 megabytes, and people start complaining it's too big. And if you when you look at the Git history, then the situation is much worse in nowadays. It's over how much? 1.5 gigabytes expected this year. It's really huge. So I stepped in for the packaging of the kernel firmware in 2019 to address those issues. And I took two main strategies. One is a file compression, and another is a splitting to multiple packages. The first one, file compression is pretty straightforward. So at first, I wrote a kernel patch to add the support for the compilation file loading for the firmware on the Linux kernel. That was accepted by upstream quickly, so the material is ready. Then we just pack the compression files into the kernel firmware package. We took the XC format because it gives a better compression ratio, although the compression time is much longer, but it doesn't matter for the users. And that alone resulted in the reduction of the size of 70%. So it went to the almost 1/3. There are a few caveats, but I don't read. You don't need read so much. It's a package details. But a second point of the splitting, that was not so trivial, unfortunately. In the current situation, so roughly speaking, about 4,000 files included in the Linux firmware Git tree. And how to categorize those into into separate packages. So my solution was to take a look at the whence file. So remember that whence file lists up all firmware files. So, and this consists of the sections of the drivers. For example, in this case, the example, it shows the AMI26 driver, and it lists up the two firmware files, AMI26-/bitstream, whatever. So at first, we define the mapping table from driver to the subpackage topic. And in our example, EMI26, this is a sound driver. So this belongs to the sound. And then we know the EMI26 driver, 26 firmware files, all of them are going to the kernel firmware sound package. So that we repeat all driver sections and end up with more than 30 split packages, like a kernel firmware MDGPU or sound or MediaTek. So this division, so their split was determined by roughly estimated sizes of each group. So sometimes it's a hardware component, sometimes it's a vendor or driver. So depending on how many files or how much the size are. And the packaging building at the time, 2019, we used multi-build for keeping the old legacy kernel firmware RPM, also the split compressed firmware kernel firmware subpackages. Because the old packages or some old image still expected to have an uncompressed firmware files, so we provided the legacy kernel firmware RPM. this is an all-in-one package containing gigabytes uncompressed files. And for replacing that old legacy kernel firmware RPM to the new split package, we provide kernel firmware old RPM. This is a meta package, and it has nothing by itself, but it has RPM requires tags to drag the all kernel firmware sub-packages. And this is replacing the kernel firmware RPM automatically. And another point of the splitting is that each small kernel firmware sub-package has a hardware supplements tag. And this is pre-processed and generated from the kernel binaries and contain, describing the module areas of the belonging the drivers. So the PCI IDs or USB IDs, whatever. And by adding that information, you can install any missing kernel firmware sub-package just by zipper install new recommends --no recommends. I know it sounds strange, but it means that you install only the hardware supplements without recommends tag. Otherwise, it will install the recommends package, and there will be too much. So anyway, they recap the change of the 2019. So for the size problem, we took divide and conquer approach, and more than 30 packages with compression are created. Also, the kernel firmware all package is provided as a replacement of the old legacy kernel firmware. And it resulted in a more than 70% reduction. And also the selective installation is possible too. That all sounds nice, but our adventure continues. The next problem is frequency matters. So last year, the Linux firmware Git tree received more than 1,000 commits in a year. So that means what? Well, next year will be even more. Expected almost 1,500. In any way, that is accelerated in the recent years. And so there was a problem by thousands commit in a year. The packaging of the kernel firmware in the state of the 2019, we built from the single spec file for the old kernel firmware sub-packaging. That means if you update something, if you receive an update in the Linux firmware Git tree, just only one piece of the file out of the 4,000 files. Then it triggers the reboots, the updates about all over 30 sub-packages. And that means if user had installed all these packages, they would have to also install, update all these packages in every week. So in every week, you will update 1 gigabyte. It's suboptimal, if I would say that more so positively. So that I started again, working on the packaging of the Linux firmware kernel firmware, and this year. So this is the result, what I did. So first of all, the sub-package, former sub-package that were built from the single spec file are split again and placed on the individual OBS repositories and spec files, so that they can be built really individually. And for that, now a source table is created dynamically for each OBS repository, and containing only the partial contents of the Linux firmware Git tree. Also, for that, the procedure became complex, so that I rewrote the whole scripts. And finally, also the legacy kernel firmware RPM that was dropped. And that was requested because factory or SLFO didn't want to have two OBS repositories building the same name packages. So anyway, that's the thing. And the problem that of this rework was how to track the each commit of the Linux firmware Git tree. Oh, okay. And because Linux, well, Git can be capable. So you can get, you can track the change of each file on the Git tree is very easily via Git log. But remember that once file is a large single text file, and almost every commit on Linux firmware Git tree changes that file. So essentially, you cannot track that change only from the Git log. So for that solution, so we do compute a hash of the each part, each section of the once file, and check the hash between the each commit ID, each Git commit. So that in that way, you know which driver has been changed in which commit. Then you know which subpackage has to be updated. And also you can generate a change log only for the relevant commits. Now all that things has been put on the now in the Git repository and kernel firmware tools on the OpenSUSE GitHub. So this is a Python script or most of the Swiss Army knife things. So they're doing most of the things. And at the same time, then we created a new OBS development project, Kernel Firmware, containing all kernel firmware packages. And each package contains the package, sources are simplified to have only two tables, the partial contents of the Linux firmware Git tree table and kernel firmware tools table. So the new packages have been already deployed to the OpenSUSE Tumbleweed, also the SUSE 16, and since this year. But SUSE 15, SP6, and SP7 are still with old packages. But fortunately, for the future update, maintenance update of the SP6 and SP7 will be switched to the new style. So that's almost end, I hoped, but not yet. There is a new Git workflow. And yeah, there will be a better presentation in this conference, so I will skip the whole details. But the point is that the package source is managed now in the Git repository. And the switching will happen sooner or later to the factory and SLFO. And because our new OBS kernel firmware project is pretty new, so let's be, funky. Let's get an early adapter. So the transition to Git has already finished. And that's, thanks to Adam, that was pretty easy. And the result is found in src.opensuse.org kernel-firmware Git project and Git repository underlying that. Also, the kernel firmware OBS project has been also switched to the Git-based. It means that when you look at the OBS meta project output, then you see that there's SCM sync line pointing to the Git project. So that means that all repository under this kernel firmware are managed by Git. So the user will have to do OSC fork instead of OSC branch for managing the kernel firmware Git. And the scripts have been also modified and updated to manage the Git repositories. So the results so far is fantastic. Partly. Transition was completed and working. That is the most important. However, the steps are more complex. So starting from the Linux firmware Git tree update, then update our Git repository, push to the Git repository, then check the OBS build and so on. Then sending peer pull request, again checking, then finally sending pull request to the factory. So we need more automations. That's the next thing to do. That's still not end, unfortunately. We still have some problems, you know. That's always found adventures, yeah. So the biggest problem is that kernel default RPM has still recommends tag kernel firmware. So that means the user will end up with full installation of kernel firmware packages. The workaround for that is just uninstall kernel firmware all things from your system once, then install only the necessary ones, then lock kernel firmware all packages. But this step should have been provided in somehow standard way. Yeah, that's still missing. Also, an open question is about how to handle hot plug devices. So you never know which firmware will be required for in the future, what you plug in. So we might want to have some basic firmwares always installed, maybe, yeah. And a better way to, at installation time and package management. As I said, the kernel firmware recommends tag is not the optimal. So we might want to move to the patterns or whatever. Also, there were Jira tickets or Bugzilla tickets for the YAST and other things, but things didn't proceed, unfortunately. So this is a big missing piece. Yeah, so that means that, yeah, adventure doesn't still continues, but the time is up. So the final remarks. So kernel firmware package started from a very simple Linux firmware Git tree copy, but it has evolved very much for the scaling problem. And now it consists of split and compressed firmware files. And now managed with semi-automatically by scripts. And we adapted Git workflow, but still have many problems to be solved. Yeah, that's all. Thank you.
Hi, I have a question. When you did the part of splitting the one spec file into multiple topic spec files,
Yeah.
so do you generate those automatically with the firmware tools, or how do you maintain this split set?
Yeah, so that I had to determine which topics should be created. That's initially was done manually. And later on, maybe I can show there. Oh yeah, that can be. This is a kernel firmware tools Git tree, and we have the topics list. That's a static listing of each topic and matching the driver to the topic matching. And fortunately, that's so the new drivers addition are even rare. It happens in 10 times per year or so, but not every week. So we can track down it by some semi-manually. Yeah, so that means that we can also modify the topic mapping table if we want to split even more fine. Yeah, that's also possible by adjusting the table and applying the packaging.
So I have a question. Would the same thing regarding splitting to multiple packages be? Would it make sense to do it also for modules, or Or kernel modules themselves don't occupy that much space. I actually have no idea.
Well, that was also my initial thinking, that provides really each module. So I mean the sub package for each module, but I thought it would result in too many packages.
Well, there has been a long discussion about that, and the outcome is mostly that we do not know how to split it.
I mean, there's a
There is no clear
package itself.
There is no clear answer for how to split it and what should be installed by default.
Yeah, that's true.
I keep wondering whether the split between different subsystems is optimal. From the point of view of the end user, almost end user has a sound card, but hardly anyone has more than one sound card, or two or three. So where you just have to pull in the entire sound card package. Well, you need just one firmware blob actually. So I know it's of course hard to think of something better, but I'm wondering, maybe we can come up with a smarter way to do this.
Yeah.
Only if it was that simple, because these days, if you have headphones, it could be USB sound card. So you never know when you are going to need the firmware. And if you are somewhere and you just plug in the headphones and it's USB sound card and you need internet to download the firmware for that just to work, you would be complaining, right? So that's the main problem with how to split it, what should be installed by default. And the answer is, who knows?
Yeah. Also that, for example, in the case of the kernel firmware sub-packages, some packages are actually split to each module. For example, the Atheros ATH10K, ATH11K, 12K, that's because they have many firmware files only for the single module, single driver, and the size is large. So that's why it's not only the kernel Wi-Fi, kernel firmware Wi-Fi, but it's split to the different for each set of the module, for example. So this is a question of how much size is acceptable and how is convenient. Yeah.
Yeah. So the goal is probably clear. You want to avoid unnecessary modules or unnecessary firmware files, which means you should just split it by the board that is used by the end user. Unfortunately, that creates some other issues. Like first, we don't have any overview of hardware and which devices are on that hardware and so on and so on. Plus the same modules or same firmware files are needed on multiple platforms. So I don't know, like either we accept some duplicates, which means, is it a problem for RPM to install the same file from multiple RPMs as long as they are identical? I think that works.
It's allowed, but it can be a problem. I think the zipper complains.
Does it? Okay. Because I think RPM can handle it. If you have
Yeah.
the same file from multiple packages and it's the identical, like bit by bit, same content, it still accepts it. But yeah, because in that case, we don't have a solution. There is no solution.
Right. The problem would be that if there's something is updated, then provided by multiple packages, then it will conflict. That's not so trivial, unfortunately.
So either you would have to go with package per module granularity, or there is no solution.
Yeah, this is still open question. Yes. I think it's a time up and everyone is hungry, right? Okay, thank you very much.